Hello students, welcome back to the lecture number 7 of chapter 5. In the previous lecture, we have discussed about 7 most important geometrical terms with the definition, such as collinear points, non-collinear points, intersecting lines, parallel lines, system of parallel lines, concurrent lines, as well as congruency of two lines. And in this class, we will discuss about the remaining 4 most important geometrical terms with their definition. So let's start with the first geometrical term, whose name is betweenness. Okay, so what is the betweenness? Here the statement is, if there is a point C lies in between 2 points A and B, so that A, C, B are collinear. Collinear means they should lie on the same straight line. Okay, then AC segment plus CB segment is equal to AB segment. Again I am saying the statement, if there is a point C which lies in between 2 points A and B, okay, so that these 3 points should be collinear. It means they should lie on a same straight line, then the length of this segment AC plus the length of this segment CB is equal to the length of total straight line or total segment AB. Understood? For example, if I take AC to be 4 centimeter, CB to be 6 centimeter, okay, then what is the length of the total segment? The length is AB. Then AB is how much? 4 plus 6. Okay. So you can write AB is equal to 4 centimeter means the segment AC plus 6 centimeter means the length of the segment CB is equal to how much? Is equal to 10 cm. So this is the statement. Understood? Now you can write what? If C is a point lies in between A and B such that A, C, B are collinear, then length of this segment plus length of this segment is equal to length of the total segment. Okay, so write it. If C is a point lies in between A and B such that A, C, B are collinear, then this length plus this length is equal to AB. Understood? Next thing, the next term is midpoint. Midpoint means if there is a line segment, then the middle position or the middle portion of that line segment is known as midpoint. Okay, so here the statement is, if AB is a straight line, okay, then C is a point on that straight line okay. So first understand this. If AB is a straight line, so you have to draw AB as a straight line. Then C is a point on that straight line. C is a point on that straight line such that C is known as the midpoint. Okay, so on this straight line there is another point, that is C, and C is known as the midpoint. Midpoint means C must lie at the mid position, at the middle position in this line segment. Understood? Suppose this length is 10 centimeter. Okay, then the point C should lie at which centimeter? Midpoint means this point divides the total segment into two equal halves. If I break this marker at the mid position, then I will get two portions. Then each portion must be equal, right? That means this midpoint bisect or divide the line into two equal halves. Okay, so that C is known as the midpoint. Then AC is equal to CB. What is it? See, as I have told you, if this length is 10 centimeter, then C must lie on which centimeter? 5 centimeter. It means the distance from A to C is 5 centimeter and the distance from C to B is also 5 centimeter. So it means what? It means the length of AC is equal to the length of CB, right? That's why I am writing the length of AC is equal to the length of CB. Why? Because C is the midpoint. So here the point C divides the line segment into two equal halves. You can write it here. The point C divides the line segment. Which line segment? Line segment AB into two equal halves. What are those two equal halves? First half is AC and CB, and the length of AC and CB must be equal. Why? Because this is the midpoint. Okay, and since the point C lies in between 2 points A and B such that ACB lie on a straight line, then we can write what? AC plus CB is equal to AB. As you discussed here, if C is a point lies in between A and B, then we can write AC plus CB is equal to total length AB. Here also AC plus CB is equal to total length AB. Right? Now, here we can write AC plus. In the place of CB, we can substitute AC. Why? Because as we know, this distance is equal to this distance. So in place of CB, you can write AC is equal to AB. Hence, AC plus AC is 2AC. 2AC is equal to AB. So the length of AC is AB by 2. 2 goes to the right hand side. Hence, AC is equal to 1 by 2 into AB. That is half of AB. Okay. So what is the length of AC? Here the length of AC is half of AB. It is proved now that the length AC is the half of the distance of the total line segment AB. It is proved here. Similarly, as you know, AC is equal to CB. Since AC is equal to half of AB, it means CB also half of AB. Okay, hence this distance is the half distance of the total segment, and this distance is also half of the total segment. Condition is if C is the midpoint. Right? So this is the second term. Now coming to the third term, that is opposite rays. What are the opposite rays? The statement is two rays are said to be opposite ray. This is a ray, suppose its name is OA, and this is another ray whose name is OB. Here another ray OA, here another ray, suppose this is OC and this is OD. Okay, so the statement is two rays. Here we have two rays OA and OB. Here also we have two rays OC and OD. So two rays are said to be opposite if they have a common origin and if all the 3 points are collinear. Okay, what are the conditions? Here you can write two rays are opposite if they have a common origin. See, in this two figure we have a common origin. Okay, this ray starts from O and this ray also starts from O. Here the ray OC starts from O, here the ray OD also starts from O. So they have a common origin. Two rays are opposite if they have a common origin. And there is a second condition. What is the condition? The condition is A, O, B points should be collinear. Okay, and the 3 points should be collinear. Collinear means what? It means BOA. If we join them, then they will form a straight line. Okay, that is the definition of collinear. 3 points are said to be collinear if they lie on a straight line. Similarly, here the point A, O, B are straight line. Okay, or they are joined to form a straight line, so that these 3 points are collinear. And this is the condition of opposite rays. So here you can see these two rays have the same or common origin, and if you join these 3 points, then they will form a single straight line. It means these 3 points should lie on the line, and these 3 points are known as collinear points. Now in this case, though the two rays have the common origin, but they are not form a straight line if you start or if you draw a straight line. See here, if you draw a straight line using the point C and O, the point D doesn't lie on this straight line. Again, if you draw a straight line by joining the 2 points D and O, then the point C doesn't lie on this straight line. So C is a non-collinear point. Here also D is also a non-collinear point. Again, if you join the 2 points D and C, then also the point O doesn't lie on this straight line. So in this case, the 3 points are not collinear. They are non-collinear points, so that they will not lie on a single straight line. Hence, these 2 points or 2 rays are not opposite rays. But here in this case, the 2 rays are opposite. Okay. Let me tell you one more example. Here it is a point, and through this point we have a ray OM. Okay. Now I will draw another ray OM. Now tell me whether these 2 rays are opposite rays or not. Since the 2 rays have same or common origin, and the 3 points, if we join, then they will form a straight line, as these 2 rays are opposite rays. But if this is a ray OP and this is another ray OQ. Okay. Now you can see, though the 2 rays have the same origin, but they do not fall on the same straight line. If you draw a straight line joining O and P, then Q doesn't lie on the straight line. That means Q is a non-collinear point. And if you join the point Q and O, then the point P doesn't lie on this straight line. That means P is a collinear, non-collinear point. So they do not form a opposite rays. And now we will discuss about the next geometrical term, that is consistency of a system of axiom. So what is the meaning of system of axiom? System of axiom is a system which contains more than one number of axioms or more than one number of self-evident true statements. As we know, axioms means what? Axiom means they are the self-evident true statement. Suppose I have 3 statements, okay, and these 3 are true statements. Then these 3 are combinedly form a system of axioms. Understood? So now we have to prove here whether a system of axiom is consistent or not consistent or inconsistent. Okay, we will discuss about what is the meaning of consistent, inconsistent in this statement. So let's understand the statement. So it is given that a system of axiom is called consistent. So a system of axiom is said to be consistent when here is a condition. If it is impossible to deduce a statement from this axiom that contradicts any previously proved axiom. Okay. Now we have to first understand this concept clearly, bit by bit. Okay, let's understand. Suppose, assume that I have three true statements. Okay, suppose I have three true statements. Statement 1, statement 2, statement 3. And these three statements are what? True. True statement, true statement. Then three statements are combinedly form what? A system. System of axioms. True statement means this is also an axiom, this is also an axiom, this is also an axiom. Okay. So these three statements are already given or are already with me. Now, if by analyzing these three statements I get a conclusion, I draw a conclusion. Okay. By analyzing this three statements, if I draw or if I deduce a conclusion, if I draw another statement. Okay. Now you understand? From this three statement, I analyze it, then I deduce or I draw another statement. If the statement that I deduce does not disapprove all the statement, does not disapprove means if this statement does not contradict all three statements, then such type of system of axioms are called consistent. Okay, let me tell you in detail. Suppose we have a system of axiom in which we have taken three true statements. Okay, so we have a system of axiom in which we have taken three statements. The first statement is no whole number is equal to its successor. It means what? Whole number. Whole number means n star. It is the set which contains the number starting from 0, 1, 2, 3, 4 and so on. These are known as whole number. Is equal to its successor. What is the meaning of successor? Successor means a number which just lies after another number. It means what is the successor of 1? 2. What is the successor of 2? It is 3. What is the successor of 10? It is 11. Okay. So successor is the number which lies just after another number. Okay. So now we understand the meaning of whole number and successor. So the statement 1 it is given that no whole number is equal to its successor. It means none of this whole number is equal to their successor. It means 0, its successor is 1. According to the statement, 0 and 1 are not equal. Suppose you have taken 10, its successor is 11. According to the statement, 10 and 11 are not equal. Is it true or false? Yes, it is true. That's why it is a true statement. Or you can say this is your axiom number 1. Clear? Next, suppose I have chosen another statement. That is statement 2. X square minus x square is equal to x square can be written as x into x because x into x is x square minus this x square can be written as x into x. Right? Now, here from this two term you can take xh common. So the remaining terms will be x minus x. Clear? So you can write x square minus x square is equal to x whole into x minus x. This is your statement number 2. And this is also true statement. Why? Because x square minus x square can be written as x whole into x minus x because x square is x into x and this x square is x into x. So this is also true statement. So you can write it as axiom number 2. Next statement, suppose I have chosen a statement, it is statement number 3, x square minus x square is equal to. See, as we know according to the identity rule, a square minus b square is how much? Is a plus b whole into a minus b. Similarly, if I take this x as a and this x as b, then the formula becomes a plus b whole into a minus b. So a means what? A means x. So x plus, and b means what? B means also x. So x plus x whole into x minus x. Understood? So here x square minus x square is equal to x plus x into x minus x by using the identity rule a plus b into a minus b. That means it is also a true statement. Here it's a true statement, or you can write it as axiom number 3. So we have 3 true statement or 3 axioms, and these 3 axioms are combinedly form a system. Okay. Now we will deduce, or we have to draw out a conclusion from this statement. See, in statement number 2, you have x square minus x square is equal to x whole into x minus x. Here, this is the LHS portion, LHS, and here this is the RHS portion, RHS. In statement number 3, it is given that x square minus x square is equal to x plus x whole into x minus x. So here it is LHS portion, and this is your RHS portion. Now look at statement number 2 and statement number 3. In statement number 2 and in statement number 3, if you compare them, then you can see that both statements LHS are equal. Here also we have x square minus x square. Here also we have x square minus x square. Okay, so their LHS are equal. That means we can write that their RHS must be equal. Okay, suppose you have a plus b is equal to 180 and c plus b is equal to 180. So in this two equation you have the RHS same, then you have to write their LHS must be equal. A plus b is equal to c plus b. Similarly, in statement 2 and 3 their LHS are equal, so you can write their RHS must be equal. Okay, so let's write from statement 2 and statement 3 we got what? The RHS will be equal. That means x whole into x minus x is equal to x plus x into x minus x. Clear? Next, here x minus x is multiplied. Should take it to the right hand side. So in the right hand side we have x plus x whole into x minus x. When this x minus x is taking to the right hand side, it will be divided, because in the left hand side it will be multiplied. So x minus x. Now see, this and this term can be cancelled out. Why? If we have 3 into 2 divided by 2, then we can cancel 2 into 2 because they are the same number. Similarly, x minus x, here also x minus x, so this two number must be cancelled out. Now we have x is equal to x plus x, implies x is equal to x plus x are 2x, right? Now this x can be written as 1 into x, this 2x can be written as 2 into x. Okay, now take x to be the right hand side. In the right hand side we have 2 into x. When x goes to the right hand side it will be divided, right? So here also x cancelled out. So what you get? You get 1 is equal to 2. This is the conclusion, or this is the statement that you have drawn out from the statement 2 and statement 3. Okay, this is the concluded or driven out statement. I can write driven out statement. So what you get from this statement? You get that 1 is equal to 2. See, 1 is a number, its successor is 2, and according to the statement driven out from statement 2 and 3, we get that 1 is equal to 2. It means a number is equal to its successor. This is the conclusion that we have driven out, or that we have drawn out. But here in statement number 1, what you find? You have taken that no whole number is equal to its successor. That means 1 can never be equal to its successor 2. But after drawing the conclusion, you get that 1 is equal to 2. Understood? So this statement disapproves the statement number 1, or this statement contradict the statement number 1. Understood? So here you can write the driven statement contradict the statement 1. In statement 1 you have taken 1 is not equal to 2, but here you get 1 is equal to 2. That means this and this two statements are opposite of each other. So it disapproves the statement 1. Hence such type of axiom or system of axiom are called inconsistent. But if this statement proves this statement, then it is called consistent. Since it doesn't prove this statement, so it is an inconsistent statement. So this is the difference between consistent and inconsistent statement. In consistent statement, the driven out or the deducing statement should prove all those previously statement. But in case of inconsistent statement, it doesn't prove the previously proven statement. Understood?